Which quant of which model should I run on my hardware? That sounds like a simple question. In practice, I read abbreviated quant notes on Hugging Face, search Reddit for somebody with a similar machine, and hope their tokens per second number use the same runtime and settings. Artificial analysis is useful inspiration for capability benchmarking, but it does not answer the local quant question on my hardware. InferGrade is my attempt to make that decision reproducible. I start in the hub with the two things that matter, my machine and my task. Here I am asking about agentic coding on an M4 Pro with 24 gigabytes of memory. The hub recommends Qwen 3.5 9B Q4KM. It shows projected capability and speed, along with a caveat. This comes from similar Apple Silicon evidence, not this exact machine. I click Measure on my machine. The hub turns that recommendation into a run plan, shows the artifact, runtime, benchmark scope, and trust forecast, then finds my paired runner. When I queue it, the job stays private during execution and the token remains in the desktop app. At this point, the hub has planned the work and handed it off. Model execution stays local. The runner sends benchmark status and the final result bundle back to the hub. This is the real runner, not a mock-up. It is paired with InferGrade.com. The managed metal runtime is ready and the hub token stays in keychain. The runner claims the queued Qwen job automatically, locks the exact llama.cpp build, runs the smoke benchmark locally with metal, and reports progress back to the hub. This fresh run completed in about a minute. A full run can measure time per task, time to first token, generation speed, memory, capability scores, perplexity, and quant fidelity evidence. The report preserves the exact artifact, runtime, hardware, protocol, and validation result, so the number can be reproduced instead of taken on faith. Dogfooding found the most valuable failures. A saturated benchmark, a 27-minute run reported as 30 seconds, a thinking model that spent its budget before answering, and interrupted runs that restarted from zero. Those became fixes in regression tests. During build week, I used Codex with GPT 5.6 Sol as my engineering collaborator. I set product direction, evidence standards, and release decisions. Codex investigated failures, implemented Python and Rust changes, added tests and contracts, and helped verify releases. GPT 5.6 helped build Runner. It does not run inside Runner. InferGrade Runner is public and Apache licensed. The goal is reproducible evidence for the model and quant that fit the hardware and task a developer actually has.